Welcome to lesson 6.4 equations. Now this lesson is very long. It's 12 pages. It's in depth. It's going to take us a while to get through it. As a result, I'm going to have to split this into segments which are easier for you to download. So I've set my timer to be for 20 minutes, and we'll just go in 20-minute segments and see how it goes. So you'll have an opportunity to make it a little bit easier for you to download on your devices or at home. So by now you're probably aware that there's limitations using tiles. One of the things I didn't do is you never saw a two-step equation in lesson 6.3. The reason for that is drawing becomes quite difficult. You would have got them on the assignments a little bit, but I would have worked through that with the classroom. I want to go through and do the two-step equations, the one-step equations using just what's called symbolic, which means that there's no tiles at all. Okay. The reason we have to do this is because you're going to get decimals. You're going to get fractions. You cannot use fraction blocks and decimals in using tiles. It just doesn't work. So let's take a look at an equation, and we're going to go through it and do what's called symbolic. So the first thing is m plus 2 equals 6. A number increased by 2 is 6. I know, and you know from inspection, that the value of m is 4. That's fine, okay? At least now you know what the answer is supposed to come out to be. But what I need you to be able to do is to do the steps that's required. So we're going to solve this plan, but we're going to do it all symbolically using the algebra. Now there's three steps you have to do for every type of an equation in algebra. One is you have to identify what's happening to the variable, and you have to do the opposite of that. This is called reverse order of operations. Now you have done order of operations before. You've heard the word BEDMAS, B-E-D-M-A-S. Now what we're going to be doing is reversing it. Sam, Deb. Okay? Now, when we're doing order of operations, you always did brackets, exponents, then you divided and multiplied, and then you added and subtracted. This always, the dividing and the multiplying, always came before the adding and subtracting. What we need to do is to reverse order of operation, which means now the first thing you're going to do before you do anything else is you're going to look for things which are added or subtracted. That is basically our steps. So I've got m plus 2 is equal to 6. The first question I'm going to ask you is, what's happening to the variable? Well, here's your variable. What's happening right there? Well, we are adding 2. That's what that is right there, the plus 2. So in order to undo or reverse it, how do you back up and do the opposite of adding 2? You have to subtract 2. Okay? Now that means that we're going to subtract 2 from both sides. Okay? And that's important. That's the third step right there. Once you've decided what you're going to do it to both sides. So this is what I've done right here. You'll see I added 2, then I subtracted 2, and I subtracted 2. You have to subtract 2 from both sides. It's got to be both, otherwise our pan balance will become unbalanced. Now, a positive 2 and a negative 2, just like there are tiles. Zero principle applies, right? What happens to a positive 2 and a negative 2? They become a 0. Well, guess what? Right there. There's our 0. And 6, with 2 of them going away, leaves you with a 4. So this becomes m plus 0 is equal to 4. So your solution, m is equal to 4. Okay? So you identify what you're doing to the variable. You figure out what it is you have to do to undo that. And then you do it to both sides. And of course, your solution is what's remaining when you're finished. Okay, turn the page. So let's take a look at how do we figure out whether you did it correctly. We know from inspection that m is 4. But how do you prove that? Well, remember our trial and error from before, where we choose a number and try to check whether it was correct? This is what we're going to do. We said that we thought the answer was 4. Well, if we think m is 4, let's take our equation, write it down, take out the m, and put the 4 in its place. If we're correct, our pan balance, should stay balanced. If it doesn't stay balanced, it's wrong. That means we made a mistake, and 4 is not the answer. If it does stay right, then we know we did it correctly. So 4 plus 2 is 6, and that's what's on the right-hand side. So since 6 is equal to 6, your answer has to be correct. There's no mistake. Now, don't just throw this down when I ask you to verify and just say, well, I know I'm right. Make sure you check it, because if you don't check it, you won't be able to catch your errors. Okay, let's try another example. M increased by 6 is 31. What am I doing to the variable? Well, you should have recognized that here's the variable. This is what I'm doing to it. I'm plussing 6. So what is the opposite of adding 6? We're going to subtract 6. So we have to subtract 6 from each side. So what does that look like? Well, you're going to put your equation down. M plus 6 is equal to 31. And then you're going to take 6 from both sides. And a positive 6 and a negative 6 become 0. And 31 take away 6 is 25. So we know that M is equal to 25. Now, we're going to do what's called a verifying. Double check to make sure we're correct. I said that I thought my answer, M, was going to be 25. So let's find out. If M is 25, I'm going to take my M out and put 25 on its left-hand side. So M's gone, 25 is in its place. What is 25 plus 6? If it is actually 31, I know I did it correctly. And we know that 25 plus 6 is actually 21. So, since the sides are equal, you could also use the word balanced there, the solution has to be correct. So I know that M equals 25. Now, this may not seem like a big thing, but it's kind of like having the back of the book tucked in your pocket all the time. Whatever you get for an answer, you can stick it back in to find out if you're right. And if you get the right answer, you will get the left side and the right side balancing. Okay, here's one that's got us to create the equation. So what I'd like you to do is take a second, see if you can come up with the equation for this. So pause the recording and create the equation. Don't go any further. Bob has some chocolate bars. He bought 4 more and now has 13. Bob has some chocolate bars. He bought 4 more. He now has 13. There's your equation. Okay? So, what am I doing to the variable here? I've got b plus 4 is equal to 13. What am I doing to this equation? Well, there it is right there. I'm adding 4. What's the opposite of adding that 4? We're going to subtract 4, so that means I have to subtract 4 from each side. So what does that look like? Well, I still have my b and my 4 positive tiles. I'm going to put with my negative 4 with it. I'm going to take my 13, and I'm going to put my negative 4 with that. So now I'm going to figure out what the 0 principles are. This here, they cancel, so b has a 0 principle take place. 13 take away 4 is 9, so I know that b is 9. Now, let's find out if I'm correct. To verify my answer, I'm going to put down my equation. B plus 4 is equal to 13. I said my answer was 9, so take my b out, put your 9 in its place. And now, does it balance? 9 plus 4 is actually 13. So I know that since my left side and my right side are equal, the answer is 13. So Bob started with 13 chocolate bars. Started with 9 chocolate bars. Okay? Let's go to the next one. So now that you know how to solve equations using subtraction, which means you put a negative with the positive you're given, let's go and do the next one. Okay? Here we've got x minus 5 is equal to 3. So what am I doing to the variable? Well, here's my variable. That's what's happening. So I'm minusing 5. What's the opposite of minusing 5? I'm going to plus 5. So I need to add 5 to both sides. So I've got my x minus 5. There's my equation. And now I'm going to take and add 5 to both sides. The reason I'm getting and adding 5 is I need this to go away, become a 0, so that I have the x by itself. So that becomes a 0. 3 plus 5 is 8. So that means that x is equal to 8. Now, I'm not going to verify this, but I'm going to do a quick check. There's a difference between check and verify. Verify means you have to write it down. Check means I'm just going to take my 8, and just for a second, I'm going to imagine this is an 8. What's 8 take away 5? 3. So I know I did it right. Okay? How am I going to mark this? Well, you write down the equation, tell me what you did, what you got, and what the answer is. So I need to see 4 marks here. Okay. Going on to the next one. M take away 4 equals 32. What am I doing to the variable? I'm taking away 4. What's the opposite of taking away 4? Adding 4. So what do I have to do? I'm going to add 4 to both sides. So what does that look like? When I write down my equation, M take away 4 is 32. I'm going to add 4 to both sides. There I've added 4 to both sides, added 4, added 4. Now, zero principal happens on this side. Negative 4 and positive 4 becomes 0. 32 plus 4 is 36, so my answer is 36. Now, the question here goes on to say, verify. Now, verify means that it wants you to actually write down and prove you got the right answer. So, verify is very simple. How many times have you heard formula, substitution, answer? Formula, substitution, answer. 36 take away 4 is 32. So is my answer correct? Yes. Turn the page. Negative 5 is the result of a number decreased by 6. So what am I doing here? I'm going to decrease a number by 6. So I'm taking away 6. What's the opposite of taking away 6? I'm going to add 6, so I have to make sure I add 6 to both sides. So let's take a look at this. Got negative 5. Write down the equation. Sometimes we put brackets around it just to make people understand that's a negative 5. So I've got negative 5. I'm going to add 6 to both sides. Plus 6 is equal to x take away 6 plus 6. On here, I got my zero principal taking place. So that's x take away 0. Over here, a negative 5 and a positive 6 is a positive 1. So your answer, x is equal to 1. Let's verify it. I had negative 5 is equal to x take away 6. I said that my answer was a 1. And 1 take away 6 is negative 5. So I know that I did it correctly. Okay, let's have you try one on your own here. Okay? Actually, maybe I'll do this one with you. I've got x take away negative 3 is equal to 9. So if I'm taking away negative 3, what's the opposite? Well, let's take a look. What are we doing to the variable? I'm taking away a negative 3. Treat the negative 3 just like you would treat any number. What's the opposite of subtracting a negative 3? I'm going to add a negative 3. Okay? So I need to add negative 3 to both sides. So if I have x, take away negative 3, and I add negative 3. Actually, I should put my equation down first. All right, and on my left-hand side, it's done. My right-hand side, I'm going to add, that should be negative 3 plus negative 3. Okay? Now, this causes problems for a lot of people. X, take away negative 3, add negative 3. It just, for some reason, when people look at it, they just don't quite understand that it's 0. Okay? If I took away 3 negative tiles and I put 3 negative tiles back, the result change is going to be a 0 change. If you have any difficulty, take your calculator and go x, go negative 3, negative 3, plus negative 3, and that would also give you a 0. This is the one that causes some difficulty for some people. All right? The most important part about this one is, whatever you get for an answer, double check it. Okay? Make sure you go back and double check it. All right? Because if you get the wrong answer, this is where your verify will actually really help you. So let's go to the verify is on. I hope I get it on the next page or not. Either way, we're going to verify this one. Yeah, here we go. So here's the question. I have negative 5. No, wrong one. Get the right one here. X minus negative 3 is equal to 9. I said my answer was equal to, let's go back. I think I made a mistake here. Oh, I'm okay. Okay, so I have to add negative 3 to both sides, 6. So let's take a look and see if we get this right. So I got 6, take away negative 3, is equal to 9. I said my answer was 6. So Remember, when you add the opposite, this becomes 9 is equal to 9. So I did it correctly. All right? I had a little mess up in my notes. That's why I'm hesitating. But there's your answer. We calculated our answer to be a negative 6, or positive 6, right here. All right? And when we verified it, we found out that 6, this is our 6 that we put in place of the x, 6 take away negative 3 is equal to 9. Remember, when you add the opposite, doing integers, okay, that becomes plus positive 3. This is where if you had trouble with integers, it can come back and haunt you. Okay? Okay, so now, so much for adding and subtracting. Let's move on to the next part, which is multiplying and dividing. The multiplying and dividing part is going to be the beginning of the two-step stuff that we're going to be doing. So let's take a look at this. Now, the three questions that we have to ask ourselves don't change. Okay? Now, remember I told you before that if you had 3 times m, we would slide them together to be 3m, and that meant multiplying. So when I say 3m, what's happening to your variable? You're multiplying by 3. Now, when you want to undo multiplying, what's the opposite of multiplying? That's dividing. So divide by 3. And of course, that means you're going to divide by 3 on both sides. Now, I told you before that we're going to get away from using the little divide sign. So 3m divide by 3 is no longer going to be allowed. Okay? I want you to put it in fraction form. Okay? Now, the fraction form looks like this. Here's the equation. 3m is equal to 12. I'm multiplying by 3, so to undo that, I'm going to divide by 3. Put both sides over 3. Now, when I bring the 3's together, 3 divided by 3, anything divided by itself is 1. Okay, that means that 3m over 3 is the same as 1m. 12 divided by 3 is 4, we know that. So that means that one of these m is equal to 4. Now, we've done this before when we did our tiles. Okay, I'm not going to draw it for you, but you can double check. This would be the one where we would have m and 4, m and 4, m and 4. So here's your 3m, and here's 12 on that side of the pan balance. When we separated them all out and grouped them, this part here where you have 1m is equal to 4, that's what this line is right there. Okay? So that means that our answer, m, is equal to 4. Okay, now go over it, look at it again, replay this section if you need to. Let's do another one once you're ready. Oh, sorry, I guess we're going to talk about the verifying first. So if I said the answer m was equal to 4, let's find out if it works. Take the m out, put the 4 in. Does 3 times 4 equal 12? It actually does. Okay, so let's take a look at another equation using the dividing. When Bob doubles the amount of people that showed up at his party, he gets 16. How many people were at Bob's party originally? So we've got 2x is equal to 16. I gave you the equation, so it's pretty easy for you to figure out. So what am I doing to the variable? Remember that 2x is the same as 2 times x. And this is why we don't use the multiplication sign. Is this 2 times x, or is this 2xx? This is why we get rid of this part and just slide them together. So 2x is equal to 16. So I need to know what I'm doing to the variable. I'm multiplying by 2. What's the opposite of multiplying by 2? I'm going to divide by 2. So I need to divide both sides by 2. So 2x equal to 16. So I've got 2x over 2 is equal to 16 over 2. Now 2 divided by 2 is 1. 16 divided by 2 is 8. Okay, so that means that x is equal to 8. So 8 people showed up for Bob's party initially. This here is now do the same to both sides. Kind of missed this of the equation. Should have had a longer blank. All right? All right, so let's verify to make sure we got this correct. I said my answer was 2x is equal to 16. I said that x was equal to 8. So if x is equal to 8, take out the x, put the 8 in its place, and find out, does the left side and the right side stay balanced? If it does, we know it did correct. We did it correctly. 2 times 8 is 16, and since it balances, we know that we have the equation done correctly. Okay, here's another one. 19 is equal to 3k. What I'd like you to do is to solve this one yourself. So off you go, pause the recording, and try it yourself. I will let you know that you will get a decimal in this one. All right, 19 is equal to 3k. 3k means we're multiplying by 3. Okay, all right, I've just had my timer go off, so I'm going to pause and set this up to go on to another step, or for another video. Separate this up, so just give me a moment. This is the end of part 1. We'll continue with part 2 in a moment.